You absolutely need to know the algebraic rules for exponents and radicals before SAT day. This question involves applying several of these rules. Whenever we have a product or a quotient under a radical, we can break it up as the product or quotient of two radicals. And the same is true for exponents. However, make sure you don't try to break up exponents or radicals over addition or subtraction. Neither of these are mathematically valid. So going back to our problem, since there's a product under each root, we can break each one up into the product of two radicals. And now I think it's helpful to rewrite these radicals as fractional exponents. If we have the nth root of a number, that's equal to the number raised to the 1 over n power. And if the number in the radical is already raised to a power, then that power is in the numerator and the index of the root is in the denominator of the fractional exponent. Now, this is a rule that you should definitely remember. And if you need help with this, just think about the roots of a tree being below the ground. So the index of our root is below or in the denominator. Now, when we apply this rule and simplify the exponents, we get 6 times 3 times x to the 9th times 2 times x to the 1/8. And now all we have to do is combine the constants to get 36 and combine the two powers of x, which brings up one more rule. When we multiply two numbers with the same base, we can write a single base and add the exponents. So x to the 9th times x to the 1/8 is equal to x to the 9 plus 1/8 power. So now we have the expression in the form ax to the b, and the easiest way to add a and b is to use Desmos. But we need to make sure when we're entering our answer, we're following the free response guidelines for the SAT math. Since the answer in decimal form is 6 characters, we need to either truncate after the fourth digit or round at the fourth digit, which means 45.12 and 45.13 are both acceptable answers. We can also enter our answer as a fraction since the fraction is 5 characters or less. So 361 over 8 is another acceptable answer. Make sure you review your exponent rules and understand the SAT free response guidelines before you walk in on SAT day.